My name is Jonathan Johnson, and like many of you, I'm a software engineer by trade. By day, I work on the CodeShip CI platform at CloudBees, where I focus primarily on improving the user interface and the Rails app that drives it. In my spare time, I also work on a tool to provide Webpack users continuous bundle analysis called packtracker.io. You can find me on Twitter and GitHub and other various internet outlets at JohnDavidJohn. Somehow I've convinced a room full of Rubyists to listen to me talk about JavaScript. Maybe that's because of the single track conference. Along with this slide deck, all code that we cover will be provided to you as a working Rails application. So don't worry if you don't quite get something or need to revisit something. You'll be able to reflect on it later. So what do I mean when I say modern JavaScript? Over the past 5 to 10 years, JavaScript has come from being an afterthought of web developers everywhere to being a language with a proper ecosystem, good tooling, and a stable-ish community of its own. As a community, JavaScript has come from sprinkling direct DOM manipulation with something like jQuery, for example, all the way to building out frameworks to encourage a more declarative style of UI development, making UI state a first-class citizen. And as Rails developers, we want to take advantage of this progress. We want to take advantage of the better ways in which these communities build UIs today. And so you're sold. You're ready to buy into these new and relatively stable tools. So you go down this rabbit hole of the web looking for tutorials, blog posts, investigating the docs of this framework or that framework. And you're digging in and everything is clicking. You've got your toy-to-do app working well, and it feels really nice to express the state of your interface with data. You're really starting to understand why we're moving away from that jQuery style approach. But you sense a problem. You're not quite sure how this translates into your day-to-day work. You're having trouble making a connection between the getting started guides and the application you're actually trying to improve. Why is this? What assumptions do these guides often make? The allure of the Greenfield project, filled with potential for architectural purity, but also filled with nothing at the same time. Most of these resources start you from scratch, right? They assume you have zero baggage, that you're not tied down by technology choices made 3 developer generations ago, which these days is like 2 years-ish. That if you have an existing application that's worth tearing down, to re-implement. And then there's this whole bias for single-page application architecture. They assume that even if you were starting from scratch, that a single-page app would be a good fit. Much common wisdom these days comes across as if single-page application architecture is the only option. And while it has its merits in situations, it's not the only option. Sometimes it's the wrong option. They also often assume that you don't have a UI at all, but you do have a fully finished API. Or at least an API that's someone else's problem. Do these assumptions describe your situation well? Anyone? It didn't match up with ours either. So if these assumptions don't quite match up, what assumptions would? We've got a running product, right? With paying customers. These customers expect us to advance the platform. So we can't spend months simply re-implementing features that they already find valuable and already work. We can't just scrap it and start over. And that's because we're dealing with many constraints. We've got those technology choices that have built up over time, made by many developers that aren't even working on the product anymore. We've also got an established Rails application and a pile of JavaScript. And unfortunately, or fortunately, depending on how you look at it, that pile of JavaScript is providing value to your users, and you can't just nuke it. You also have an API-ish, right? So where did we start in real terms? If you can't look at this list and identify with it, you can at least get a little bit of nostalgia, I'm sure. We had ourselves a 5-year-old Rails application, and as I like to call it, a mature Rails application. jQuery all the things, everything is global, even with some jQuery UI goodness mixed in there. We had no meaningful test coverage over this JavaScript outside of our capybara acceptance tests. Our JavaScript codebase was reflective of the time in which it was created. These things haven't necessarily aged poorly, any more poorly than any technology choice usually does. They've just simply aged. The JavaScript world has moved on significantly, and we want to move along with it. So we've defined where we're starting. Where do we want to end up? What are our goals? As I mentioned previously, we want to leverage this progress in the JavaScript ecosystem, take advantage of the modulification of JavaScript, use the newer frameworks out there, and leverage a more data-driven approach to interface development. We chose Vue as our framework of choice, so most of what we'll talk about today is Vue-centric, but many of the concepts and approaches can be translated if you're considering a different framework. Even though we're buying into more modern JavaScript approaches, we don't want to divert too harshly away from the Rails way. What if we thought of JavaScript components as upgraded partials? A different type of partial when you need some of that on-page interactivity. We also don't want to re-implement things that Rails is already good at. All the ways it really enhances our productivity, routing, forms, the general HTTP lifecycle, etc. Rails is really good at that stuff, and let's not take that away. And on the flip side, we also want to let Vue be Vue 100%. One reason we chose Vue was its flexibility, but we do want our Vue usage to reflect the documentation, so it's easily digestible by those that come behind us. We want to be able to easily leverage all of the tools and best practices of the Vue community. And lastly, we want to build an environment where testing our JavaScript components is as intuitive as testing our Rails models. We want our machinery to encourage JavaScript component testing, assume it even, in the same way that Rails assumes the testing of our Ruby code. So with all this in mind, let's get started. A big first step in our journey to revamp our JavaScript workflow at CodeShip was to introduce Webpack via the Webpacker gem. Webpack itself is an alternative front-end build tool that is similar in role to the Rails asset pipeline in many ways. You're likely very familiar with the asset pipeline. It's a very focused tool and has served the Rails community well for a long time. So why move on to something else like Webpacker? With the advent of Node.js and the NPM registry, JavaScript is no longer solely a browser runtime with the assumption of a top-level global scope. We have a proper package and module system to express dependencies and the ability to require those dependencies in scoped ways. This applies to both code from the NPM registry, which is the JavaScript version of rubygems.org, for example, and also code from within your own project. It helps you to modularize and organize your own code in much more clear, concise ways. Webpack takes advantage of this module system and builds your resulting assets by using import statements to provide you with assets that include only the code it needs. No more concatenation ordering issues, no more attaching everything to the window object. And given that Webpack will be the JavaScript compiler in Rails 6 and beyond by default, I think it's a safe bet. But remember, you can, like us, move to Webpacker before you move to Rails 6 by using the Webpacker gem, as long as you're on Rails 4.2 or above. This gem provides a fairly simple configuration layer that plays well within the Rails toolchain and hooks directly into the assets pre-compile rake tasks. So it's relatively automatic. And as you can see, the community seems to be mostly happy with it. Mostly. In terms of setup, I'm not going to dig too far into how to get Webpacker up and running within your project. There's great documentation for that, and the provided repository I'll give you at the end will illustrate a working version of that. So instead, I'm going to briefly discuss the mechanics of how it works within a Rails context and how we use it to create our assets. So once Webpacker is set up, you'll end up with a few new directories. You can think of these similar to how you would think of app assets JavaScripts in the asset pipeline world, where pack is the noun that Webpacker uses to talk about Webpack entry points. And those packs will mirror the assets you produce. You can roughly think of a pack as analogous to an asset manifest file that you may be used to in the asset pipeline world. For example, if you have a JavaScript file in your packs directory, you'll end up with a processed and minified version of that asset in your Webpack output, including all required modules it needs in order to run. It will also have its content hash included in the file name, similar to how you're used to with the asset pipeline. They're just JavaScript files at this point, so what's the big deal? To illustrate, let's say we want to use an external JavaScript library within our pack. In order to do this within the asset pipeline, we may have to do one of a few things to get that library into the project and ready for use. Maybe there's a gem that distributes the JavaScript, which always seemed odd to me. Maybe you're still trying to push on with Bower or Bower Rails, even though they officially recommend that you don't. Maybe you just end up vendorizing everything inside your repository. In any case, once you have the library you want to use at hand with the asset pipeline, it might look something like this, right? We add what the asset pipeline calls a directive that includes our library. But how are we actually accessing the capitalize function here? Where is it defined? The module in question is simply being concatenated, so the most common approach in making these libraries available historically has been to attach them to the window object, making them globally available. So the impact of this change actually reaches outside this individual JavaScript file, and it's also not immediately clear where this capitalize function is coming from. This file is small, and you can easily make that connection in this context, but imagine you're using this library in an asset manifest that's normally hundreds of lines long, sprinkling its global usage across many other JavaScript files. So what does this look like in a Webpacker world? In order to track our JavaScript dependencies from NPM, we'll use the Yarn package manager. In order to do that, we use package.json to outline those dependencies. If you don't already have a package.json in place, you'll get one during your setup of Webpacker. And next, we simply add the capitalized dependency with the Yarn package manager with this command. This will add the package to our package.json file, install it, and update our lock file, similar to the relationship between your gem file and your gemfile.lock. The result will look something like this. We've got our list of dependencies and their versions. Once we have installed the module, we can then make use of it in our pack with an import statement. In the Webpack model, it's clear where capitalize is coming from. We have a scoped local import of the capitalize function, and we can make use of it without polluting the global scope with the needs of this one pack. This has many side benefits as well. For example, it's easy to tell what files are using what dependencies, making refactoring much easier. But this is where all you smart people might ask, if you include this module in multiple packs, won't capitalize be downloaded for every single pack that uses it? That is true, but Webpack does have good ways of deduplicating those required packages across assets, so you can optimize delivery in a very configurable way. For example, if you have a module import that is used in multiple packs, like for us, Vue is used in every single pack, you can explicitly tell Webpack to extract it to its own asset, along with other commonly used packages. No, I'm good. Thank you, though. Appreciate it. This is very similar to how you would think of a vendor manifest file in an asset pipeline world. Webpack does the work of making these shared imports available to each resulting pack while maintaining the scoped benefits that we discussed. You can even set up a more rule-based approach. So at CodeShip, we have it set up so that anytime a package is used more than twice, Webpack knows to pull that out into a dedicated asset. So now we've got Webpacker set up and we're creating assets. We understand how Webpack is beneficial to us. How do we get them included in our views? If you're using the asset pipeline today, this won't be a drastic change, and it might not be a change at all. The asset pipeline and Webpacker are not mutually exclusive, so you can use them both side by side as you transition, or even indefinitely, as you may still want to use the asset pipeline for other types of assets, like maybe your SaaS or images. You can introduce Webpacker in addition to your asset pipeline, and I'll talk about how we've handled that a little bit later. At this point, we've got Webpacker set up. We have our JavaScript entry points, and we're including our assets on the page. But before we get into creating our first view component, I'd like to take a step back and explain how we think about our front-end architecture at a high level. As I mentioned previously, we've got ourselves a pile of JavaScript and an existing user interface that's rendered by Rails that's providing value. So a single page application architecture just isn't possible for us. It would be too big of an investment. So we need to operate within an existing product that's already running. We can't just scrap it and rebuild, so what do? Instead of pursuing the single page application path, the way I like to describe our JavaScript UI architecture is as a multi-application page. Actually, many multiple application pages. We build each UI component as if it were its own insulated application within the existing page that is rendered by Rails. And our top-level JavaScript apps are not responsible for routing, page transitions, and other full-page services required logistically of single-page applications commonly in order to replicate standard browser behavior. We leave that to Rails in the browser. Rails is good at this, and we don't have to burden our JavaScript with things that we already have solutions for. We do, however, get to take advantage of all the power and simplicity that many of these new patterns provide, like proper state management, data-driven presentation, and testability. So what's the difference between what we're calling an app and a standard view component? Technically nothing. The answer lies more in the roles that they play within our architecture. We think of apps as smart, aware of the world around them. They handle more business logic focused tasks like Ajax. If an app is complex enough that it might benefit from using something like a Vue store for state management, it would be an app that deals with that. Apps are most often composed of standard view components. And generally, we think of everything else as a standard view component. In contrast to apps, they should be less smart. Trying to avoid the word dumb there. They should be ignorant to the world around them. They don't handle many of the things that apps deal with. They are presentation focused primarily. They take in data, and if they absolutely need to track state, it's local state only. The idea here is that these components should be easily plugged out of an app and made to be reusable if needed. Now that you have a high-level view of how we see our front-end architecture, let's cover some of the nuts and bolts of how we've actually chosen to structure and ultimately render these apps. This is an example boilerplate for what a top-level app might look like. As a side note, another benefit of using Webpacker is that it has a rich ecosystem of loaders that allow you to do things like this view single-file component syntax. Notice I've also introduced another directory under app JavaScript to contain these apps. Let's see if this works. Yeah. The first step in the process of creating and mounting one of these apps is to decide where in the rendered layout you want it to appear. Maybe it's a small individual form field. Maybe it's a full-page reactive dashboard. In either case, you decide where you want the component to show up and then add your mount point to your ERB template. Next, we create a new pack file. Add the logic needed to take a mount point and render our app in its place. If you don't quite get the view specific bits of this next section, don't worry. The gist is basically that we're selecting the mount point with get element by ID. Then we are creating the new app. Oh, this is really contrasting. And then we are rendering it at the mount point. And then finally, we have to include our pack on the page with the helper I described before. Loading our pack file on the page triggers the mounting routine, ultimately rendering the app where you want it to show up. This is, on one slide, I've taken you through the basics of what we use to get our apps from their individual component files onto the page. Next, I'm going to walk through the process we use to create a more automatic or Railsy workflow that abstracts a lot of these concerns away from our day-to-day development cycle. As we move towards an optimal end state, we discussed the idea that our view components should be as easy to work with as other Rails partials, that these components should be interchangeable, allowing you to move to view components easily once you need that extra level of JavaScript interactivity. Something you could easily reach for when you need it, but won't encumber your work that doesn't require it. So let's say we have a simple hello world partial. All it does is take in some data as locals and then renders. Optimally, what should it look like to convert this simple partial into a JavaScript component driven by view? Assuming we need JavaScript functionality, of course. A slight change in how we initiate it using our new view app helper instead of render. And with that small change, we're able to unlock the power of view to build our UIs. Obviously, we haven't talked about this view app helper yet. It's because it doesn't exist. So let's start building it. First, we discussed before, we need a mount point. That's a great place to start. We simply create a predictable way to select this mount point and then create a div. It seems like a pretty useless helper at this time, but don't worry, we've got more work to do. Notice I moved from using IDs to this custom attribute view app. We use that so that we can have multiple instances of the same app on the page at one time. So now we've got our mount point on the page where we want the component to render. We still need to include our pack that actually executes the JavaScript that mounts the app in place. To do this, we add a few more simple helpers to track which packs actually need to be loaded. Again, this is really basic stuff. These helpers simply track the packs that are needed for any given page render for later use in our layout. The only interesting bit here really is our usage of set to ensure that we have a unique set of packs. If we render multiple instances of the same app on a given page, we don't want to add a given pack multiple times. Now we make use of these helpers in our view app helper so that we produce a mount point and we also enqueue the pack that it needs in order to mount. So at this point, our page has the mount points in place, knows which packs it needs in order to execute the mounting routines. So we just add the packs to the page in your layout. If you, like us, have a pile of legacy JavaScript code that you're trying to figure out how to deal with, in this case, we decided to make a hard break on pages that include new functionality. So if we know we don't have any of our new packs to load, we turn on our old JavaScript. Quickly, we found the global aspects of our legacy JavaScript code that need to be fixed up, things like navigation or other global elements on the page. And over time, we've made good progress in transitioning more and more pages to our new JavaScript code base. Over time, this has proven to be a successful approach for us, but given there's much flexibility in this approach, you might want to consider your own goals and situational specifics. Great. So now we can create a mount point and add a pack tag in one go with our view app helper, but what good would these apps be without the ability to pass them data from the Rails side? Similar to passing locals to partials, we want to enable an easy way to pass data into our view apps. We want to create a clear line in the sand where Rails ends and view begins, and data passing between them is an opportunity to do just that. You will likely ultimately fetch some data via AJAX eventually, but if you have the data you need at render time, why not allow it to be passed in? So clearly, a first step is to allow our view app helper to accept a hash containing the props you would want to accept in your view component. This is a pretty straightforward change. First, we add our props argument to the method signature. Then we iterate over this hash, doing two things. We add this data dash prefix to all of our keys, and this is preparation for adding all these properties as data attributes on the mount point. Then we convert all of our values to JSON. Note that this actually works really great for most primitive types like Boolean classes, numeric types, and ultimately any class that implements and has JSON or toJSON. And then finally, we create a new div with both the data attributes and our view app selector. At this point, all our data is JSONified and contained in the data attributes on the mount point. The next step in the process is to modify our pack to iterate over these data attributes and pass them to our view app. These data attributes are easily accessible at target.dataset on our mount point. We simply iterate over these entries and convert the values from JSON. This system of converting to JSON on the Rails side and from JSON on the JavaScript side allows all these primitive types to transfer nicely. We'll get proper booleans, numbers, and other more complex object structures, similar to how an API might work. Lastly, we pass those to the view instance with the props data key. Remember this component? Lastly, we'll modify our Hello World app to accept what Vue calls props. Vue has a component property called props that provides a fairly simple schema format to describe the data that you're expecting. And from here, it's all standard Vue usage. We have our data from Rails, and you can use all the Vue community best practices and tools to build out your app, no matter how simple or complex. Eventually, you will want to make use of some AJAX calls, and so we decided early on to explicitly leave that knowledge with Rails. So we pass our URLs into our apps for them to use. Now that we've taken care of automating including the pack and rendering the mount point, the last bit to get cleaned up is our pack files. To this point, we've operated under the assumption that each pack would be responsible for mounting its own app. That's a lot of repetition, and since we're using Webpack, it's very simple to move that logic into its own module that your packs can consume. And before we actually talk about the actual logic, I'd like to show how exactly you can now modularize your JavaScript code internally, not only with npm packages. See here how we've used the export default syntax. This allows us to expose specific pieces of functionality from this file. You can create classes and other reusable bits of functionality that are all individually unit testable. We have many of these lib-type helpers that allow us to make reusability a priority, and Webpack helps us achieve that cleanly. Even though it still fits on a single slide, although admittedly with a little smaller font, no need to hurry to understand what's going on here. It's conceptually the same. It's just modified for more general usage and takes into account that multiple mount points may be on the page at one time. We're just getting all the nodes that match the mount selector and mounting them all. Now that we've extracted this bit of code, we can reuse it in all of our packs. Now each pack file will simply import the boot library along with the app and then invoke the boot routine, which mounts the app in place. This is what most of our pack files look like these days, only a few lines of code. Now that we have standard single file components that follow standard Vue usage, it's a fairly simple process to set them up to be tested with the well-beaten paths of Jest and Vue test utils. So I'm not going to walk through that documentation. Rest assured, again, there's a complete example, working example waiting for you. But what I do want to cover is a convention we followed that has helped us blend these testing patterns with standard Rails testing patterns. There is quite a bit of tooling that makes navigating a Rails project a breeze based on directory structure conventions, and we wanted our JavaScript test suite to also follow these conventions. So we've strictly mirrored our spec JavaScript directory structure after our app JavaScript directory structure. And we have a one-to-one mapping between our JavaScript files and their corresponding spec files. This allows us to blend into the Rails directory structure, but also take advantage of some of the tooling built for Rails developers. For example, I make heavy use of Vim and the Rails Vim plugin. And one feature that I love about that plugin is being able to have my model up and then be able to quickly, with keystroke, switch to my tests and back and forth. I really wanted that experience in my JavaScript day-to-day. And so all I had to do was create a simple projection for that plugin. And I can do the same thing with these Vue and spec files. It feels very natural. I get to leverage all that muscle memory. Another tool we created that is related to testing somewhat is a custom Vue app generator. I love using custom generators within teams. I think it's one of the underused features of Rails. And I think it really helps patterns stick. They're really great at making the right thing the easy thing. And with all the work we've done to streamline the process of kicking off new work with the Vue app, this is really what I think kind of ties it all together. It makes the whole end developer experience really nice. We've discussed the plumbing involved in hooking up one of our Vue apps, but generators allow us to make it feel more like magic without having to consider those details every time we want to add a new app. The generator will get you the bootstrapping and boilerplate ready to go, complete with the pack file, an app itself, and the spec file all right in place. The benefit here is I don't have to think about the directory structure, what the boilerplate syntax is, etc. It doesn't give me a chance to make a mistake. Then we get our standard pack file out of this generator, and now that we've extracted the boot logic, all of our pack files seldom change. Most of our pack files are generated, look like this, and they're left alone. You get a standard Vue starting point, and your spec file with a working test in it, in the right place. Ultimately, this is what we're aiming for, right? A developer experience that takes advantage of the newer approaches of JavaScript development, but also feels like it has a home in Rails. You run the generator, you add the helper to your Vue, and you get to work. Over the past few years, this pattern is shown to be able to scale the full gamut. We have apps that handle the interactions of a single form input field, but also apps that handle a full page of reactive elements. This pattern is shown to be flexible and useful so far, but I'm under no illusion that we'll look back in the years to come and need to revisit it. Hopefully you've got some useful ideas out of this talk, and remember it's never too late for your application to reinvent itself.